Okay, so basically yesterday we focused on CYS330 test 2. So basically we were covering the binaries, the ones and twos complement, and how an overflow can occur in relation to system vulnerability assessment. So in this particular session, we are going to focus on the same test 2 answers for CYS330, and these videos are now for PERT charts. So before we even start with PERT charts, we need to understand what's a PERT chart. Okay, so a PERT chart is just a project evaluation and review technique. So since this course is system vulnerability assessment, there is a time where you'll be needed to come up with a report on certain vulnerabilities. Now, sometimes management or stakeholders cannot understand your technical report, but would rather suggest you to add visuals or any other diagrams. That's where PERT charts can come in place now. Since we have an idea about the PERT chart, let's try to solve one question, and we are going to see on how PERT charts can be useful and used. So before we even start doing that, let's just read out these few notes. So as I've said, program evaluation and review technique, and that's a PERT chart, which is just a project management tool used to plan, schedule, and coordinate tasks within a project by visually mapping activities and their dependencies. Okay, now here I'll break down the terms once we start maybe with the calculations. So what I'm interested in again is the softwares which can be used to come up with these PERT charts. So in this particular video or sessions, we'll be using Hydromax. So Hydromax, you can just search it online, you can download, you can install it in Windows or Linux. As you can see here, I'm using Linux. Okay, so now since that has been talked about, let's start with our first question. So this is question 2 of the test 2. So it says mitigation and remediation requires planning in advance. PERT can be used to visualize these plans and make it easy for IT and project managers to follow through. So our first question is construct a network diagram with the given with the data given below, 5 marks. Okay, so this is our data. Okay, so here I won't be concentrating on this diagram, we'll be creating it by ourselves. So here we're just concentrating on this particular data which we've been given. So the first step which we are going to do is that we are going to open our Hydromax. Okay, we are going to open our Hydromax. So inside Hydromax here, okay, by the way, you can also do this on paper. I'm just using a software for the sake of this tutorial. So we are just going to create a blank drawing. Then inside this blank drawing, I'm going to search for PERT chart. Okay, so these are the symbols you can be using in PERT charts. So I'll focus on this particular symbol mostly because that's the one which we are going to be using to represent our nodes or starting points or ending points for our activities. Okay, now let's follow the data which we are given. So here we can see that we have activities. Okay, so activities, these are just activities taking place in your project management. Okay, so if a dependency or a predecessor is blank, it means those particular activities are coming from the start. So whenever you are coming up with a PERT chart, you always make sure that you start with the start, which is node number 1. So I'm going to drag this first node, then I'll label it as 1, meaning it's our start. This is our starting node. Now remember, we have 2 activities which have blank predecessors or dependencies. You can see A and B are blank. They don't have any dependencies, meaning they are coming from the start, which is node number 1. So I'm going to drag 2 nodes which will represent A and B So this can be our A, and this here can be our B, like that. So now I need to represent them with lines. So this is our start. This can be node A, as I've said, and this can be node B. So if we are saying this is our node A and this is our node B, that's how they can be represented. Okay, now let's continue with our activities. So now we can see that on the activities we have C, which is dependent on A. So in simpler terms, we are saying C is coming from A. So we are going to go where there is A. Since we didn't have A, that's where our C will come from. So this can represent our C, like that. So this particular node can represent our C. So let me just label it C. Okay, now we continue with our activities. So we can see that activity D is coming from B. Okay, so we go where there's our B, then we that's where our D will come from, like that. So this is our D. Let me just label it D. Now the last activity, we can see that E is coming from both C and D. Okay, since E is coming from two nodes, which is C and D, and we can see that here our C and D already exist, but we are saying E is coming. So here we are simply saying that we must have a node which is E. Now we are saying E is coming from both C and D. So we don't want to create lines, for example. We don't want to do this, whereby we have a situation like this, because we say, what is this node? What is this node? We only want E. Okay, so in this case, what we are going to do is that we are going to merge. Okay, we are going to merge these particular nodes. So here we can say, okay, let our C and D merge. Okay, let me just do this nicely. So we say anyway, I'll continue it. So we say let our C and D merge. Why? Because that's where our E is coming from. Now this makes sense. So in a situation where we have nodes, are merging, this is what we do, so that that activity which is dependent on them comes from there. Okay, now we can proceed with the durations which we've been given. Now I'll be trying to explain everything like predecessors, dependencies, activities, nodes, everything as we are going. So for now we are just taking it as it is. Now we can see that activity A, the duration is 5. Okay, so for duration is just a time it can take for an activity to be done or to be complete in your project. Okay, so we can see that activity A takes 5 days to complete. So we are going to represent activity A with 5. So here I'll just put 5 in brackets to represent 5 days. Okay, so we continue with that same approach. So B will finish in 3 days. So for B is 3. Okay, so here you can just put 3 to represent that B. Okay, then now we can see that we have activity C which is coming up. So C will finish in 10 days. So on my side, because C has a lot of maybe days with the duration, it could be wise for us to make it look as if it has a lot of days or duration based on the length. Okay, so I'm just trying to extend C so that it can make sense, more like we're trying to be realistic. So you can see that at least even the length for C is now longer than others, meaning 10 days. Okay, so I just did that deliberately. Okay, Now that makes sense. So the last node we have is E. Let me just do this. This is not on the straight line. Okay, so the last node we have is E. Now E, what's the duration? Oh, we are coming to D first of all. So D, the duration is 2. You can see it's 2. So we'll come to D and we'll put 2. So here you can put 2. Then the last node is E. So E, what's the duration? 6 days. So let's now do this. So this is 6. Okay, meaning the first part which says construct a network diagram, it means we are done. Okay, now there's just one thing remaining for us to complete. If this node is 1, okay, meaning we'll be following the alphabet. So A becomes 2. Okay, just like that. B becomes 3, meaning D becomes 4. Then E becomes 5. Okay, now we are done with our network diagram. So we are just following the question step by step. So we have our first 5 marks, but that's not 5 marks, it's almost 2.5 because we have some calculations inside, but following the question, it means we are done because we just constructed. Now here we have another question. So the next question is that compute the project duration, which is 2 marks. Compute the project duration. So by definition, we can just say the project duration is how long, okay, how long can it take you to accomplish or to finish your project. Now it's not just how long like any other way you can use until you go to the file, and I'll explain the definition as we do the calculations. Okay, now the starting node will always start at 0. Notice we are using a bottom box or section. So what we do, we say 0 plus 5. Now there are 2 things we need to understand when it comes to PERT charts. There's what we call a forward pass and a backward pass. So when we are going forward, it's a forward pass, we'll be adding. Okay, I will explain more. So what we are doing right now is a forward pass. So in forward pass we add. So we say 0 plus 5, it will give us 5. Okay, now we say 0 plus 3, it will give us 3. Okay, now we can see that node C and node D are sharing this particular node. Okay, meaning we need to make a choice. Now in a forward pass we get the maximum number after adding. So what we mean by this is that since we have 3 plus 2, the answer is supposed to be 5. Okay, now notice if we say 5 plus 10, the answer is 15. So instead of putting 5 inside this box, we are going to put 15. Why are we putting 15? Because so we are putting 15 there because in a forward pass we get the maximum value. Okay, I repeat, 3 plus 2, it's 5. We can't put 5 there because C is also sharing this node, meaning 5 plus 10, it's 15. This is the forward pass. We're going forward, we get the maximum value after adding. Now lastly, in our forward pass we have 15 plus 6. Okay, 15 plus 6, which is giving us 21, if I'm not mistaken. Yeah, 21. So 15 plus 6 is giving us 21. Now we are done with the forward pass. Now here comes another concept of the backward pass. So in a backward pass we are simply subtracting. We are not adding. We are going in reverse. So we are subtracting. So since we are subtracting, when we have a tie, we are going to get the minimum number. So let me just demonstrate, then you understand. So instead of starting at 0, we will start at 21. Now we are using the upper section. Okay, so start at 21. Why? Because the duration, the maximum duration we have is 21. So starting reverse, we'll start with the maximum going this side. So remember, this is the backward pass. Now we'll be subtracting. So 21 minus 6, the answer is 15. So we put 15 there. Okay, now 15 minus 10, the answer is 5. So we put 5 there. Then 15 minus 2, we have 13 here. So we put 13 there. Now remember, this is the backward pass. Here is how we make a decision. Notice that A is sharing node 1 and B is also sharing node 1. So if we say 13 minus 3, the answer is 10. We cannot choose 10. Why? Because 5 minus 5, the answer is 0, and 0 happens to be the minimum number. So in a backward pass, we get a minimum number after subtracting. In a forward pass, we get the maximum number after adding. Okay, now hope it makes sense. Now the question which we are trying to answer is saying calculate, okay, calculate the project duration. So before we even do that, now let's try to calculate what we call a slack. Now what's a slack? So a slack is simply the difference between these two values. So for now, I'm just saying these values, but with time, I won't be saying these values, but I'll be calling them names. Okay, we are not trying to complicate things, we're just trying to make it simple. So here is what we'll do now. I'm going to type slack. Okay, so slack is just the difference between these two values. So the slack for node 1 is simply 0 minus 0. So the answer is 0. Okay, now we come to this node, which is node 2. So we say slack. So the slack for this one is 5 minus 5, which is a 0. Okay, we continue, we come to this node, we say slack. So even though you cannot see here, there's 13 minus 3, which is giving us 10. Okay, so we have 13 minus 3, which is giving us 10. Then we come to node 4. So the slack for node 4 is just 15 minus 15, which is 0. Then lastly, we have the slack for node 5. So the slack for node 5 is simply 21 minus 21, which is a 0. 21 minus 21, which is a 0. 15 minus 15, which is a 0. 13 minus 3, which is a 10. 0 minus 0, which is a 0. 5 minus 5, which is a 0. So we know that a slack is simply the difference between these two values. Okay, lower and upper section. For now, I'm not calling them their actual names because we haven't reached there yet. Okay, now why are we even calculating the slacks? Why are they important? So there's this concept which we call the critical path. Okay, critical path. Now what is a critical path? Okay, before we even define it, how do we even calculate or find the critical path? So since we already have our slack, we can say a critical path is any path which has a slack of 0. Okay, we can see that node 1, let me just use something here. Okay, so we can see that this node, which is A, has a slack of 0. So we are going to represent this. So we are going to do this here. I'm trying to make it straight anyway. just like that. So what we've done here with A is that we are simply indicating that this path is one of our critical path because our slack is 0. So we can see that also C, or this node 2, has a slack of what? 0. So do the same. Here we can represent it because it has a slack of 0. So here we can say this can be our critical path also because it has a slack of what? 0. Now let's see, this node has a slack of 10, so it cannot be our critical path, so we ignore this one. Okay, but if we see this particular path now, here we have a slack of 0 and here 0, so E surely has a 0. So I'll just repeat, just a moment, let me just do this. So there we represent it like that. Okay, now this is our critical path. So let me just take you back again. So any slack of a 0 can represent our critical path. So we can see that from 1 to 2 we have a slack which has a 0, at least 0 0, so this is the path. Then from 2 to 4 we can see that here we have a 0 and here we have a 0, so it's okay, no wonder we've represented it. Now 4 to 5 you can see this is 0, this is 0, so this can be our critical path. And if we see 3 to 4, this is 10, this is 0, it's not 0 0, so we cannot share D. Okay, so a critical path is where we have a slack of 0. Now let's come to the project duration before we go to the critical path. Okay, so for project duration, so for project duration, this is how we do it. So we say our project duration is simply where there is a critical path or where we've shaded. So you can see here we've shaded that our duration is 5. So we'll say 5. Okay, there we'll say 5. What's happening to my battery now? Sorry for that. So there we'll say 5. Let me just remove it, I'll bring it back. Okay, so here we can see that here we have a 5, okay, because we've shaded. Here we've also shaded, we have a 10. So say plus 10. Then here again we've shaded, we have a 6. So say 6, okay. Now, let me just do this. Okay. So if you look at these particular figures now, we have 5 plus 10 plus 6, which is giving us 21. Okay, so this is giving us 21. So even by looking, we can see that our project duration is 21. So the maximum, so because it's in days, let me just finish, say days, 21 days. Okay, yeah, just like that, just trying to be neat. Okay, 21 days. So we can see that our project duration is 21 days. So that's the maximum time it can take us to finish this project. But now the project duration isn't just dependent on any other time but the critical path. Hope that makes sense. Now let's go to our next question. Since we now know that our project duration is 21 days, that's the 21 days we were seeing there. Now, determine the critical path, 10 marks. So why is it 10 marks? It's because a critical path requires a lot of calculations, as you've seen, but we've already calculated for the critical path. So we just need to identify the critical path. That's the good part now. Critical path. So our critical path now, we can say it's the shortest time which can take us to finish our project. Okay, in short, any slack of 0 is our critical path or the shortest path to finish our project, but we've already identified it. So we can see that from node 1 to 2, 1 to 2, that is our first critical path. 2 to 4, So we'll say 2 to 4, and lastly 4 to 5. Okay, so 4 to 5, that's our critical path. So we can see that our critical path is from node 1 to 2 to 4 to 5. Why? Because we've shaded 1 to 2 to 4 to 5. So that's our critical path. So it's 10 marks because of the calculations. Otherwise, once you do that, it's simple. So this is our 1 to 2 to 4 to 5. So this is the first part of our PERT chart question. So my name is Asoko James, representing KMU Cybersecurity Tutorials, and this is the CYS330 test. 2 answers specifically for PERT charts for this series, and see you in the next one once we start constructing for this question D. Okay.